All right, in today's lesson, we are going to learn about vertical angles. The essential question for today is, how can I apply the vertical angle theorem to solve angles? So the vertical angle theorem states that vertical angles are congruent. For those of you guys who don't know what congruent means that their measures are equal to each other. So if I'm looking at two lines that cross each other that made four angles, I'm going to label them 1, 2, 3, and 4. That means that angles 1 and angle 3 are vertical. And angles 2 and angle 4 are also vertical. While writing angle measures, mathematicians typically use this angle notation to notate they're talking about an angle rather than an actual number or a measure of something. So if you see this in an example, if we have two lines across each other and this measure is some x and this measures 47, well, what's the measure of x? Well, by using the vertical angle theorem, we know that x is going to be the same measure as that angle across from it, which means that x is going to be 47. Let's look at a little more complicated example, something you might be more likely to see on a quiz or test. If I have two angles that cross each other, and we say this one's 14, and this one's 6x minus 2, we're still able to apply the vertical angle theorem here. But in this case, we're going to see that 14 is going to equal 6x minus 2. And we can create that equation and say that these two are going to be equal to each other or congruent because of the vertical angle theorem. From there, we're going to solve our equation. First, we're always going to simplify the equation. So if there's any combined like terms, distributing, that's always what we do first. In this case, that is not the case because 6x and negative 2 are not like terms, so we cannot combine them. So we move on to step 2 of solving. Step 2 of solving is eliminate the number being added or subtracted to the variable. So in this case, x is having negative 2 subtracted from it. So we are going to do the inverse of subtracting 2, which is adding 2. Why must we do it to both sides? Well, if we want to keep both sides equal or balanced, whatever we do to one side, we must also do to the other. Negative 2 minus 2 cancel each other out. And then we have 14 plus 2, which is 16, equals 6x. Since there's nothing else being added or subtracted to the variable, the next part we're going to do is eliminate any constants being multiplied or divided to the variable. So in this case, 6 times x is occurring on the page. So we're going to do the inverse of 6 multiplied by x, but we're going to do 6x divided by 6. 6 divided by 6 is 1, so we are left with x equals, and then 16 divided by 6. And there's two ways I want you guys to get used to writing this. First, we need to work on simplifying fractions. Since 16 and 6 are both even numbers, we can divide both by 2 and left with 8 over 3. Those of you guys who might have punched it in your calculators, we can also see that 8/3 can be represented by the decimal 2.666, and the 6 will continue going on. This means if I take 8/3 or the decimal value, 2.66, and plug it in for x, we will get a value of 14. Let's look at one more example and kind of increase the difficulty of this. We're going to look at the two angles, 2x plus 5 and 7x minus 40. Well, we can apply a similar process to that of above, but we're just going to have a slightly bigger equation. Just as before, you're going to have 2x plus 5 and 7x minus 40 be equal to each other. Why are they equal to each other? Well, they're equal to each other by the vertical angle theorem. So we're going to set that equation off to the side. We've got 2x plus 5 and 7x minus 40. And for some students, they haven't really worked with solving variables on both sides. So I'm going to walk you guys through it. The first step is, well, there isn't actually a right step. The right step is to move any one of these. Now, due to number patterns and analyzing what you have, you would want to avoid negatives or avoid ways for you to get a number that are too many negatives involved, because often that can trip students up. But even if you do choose an inconvenient method, you will always get the same answer no matter which one you move first. So I'm going to start this off by noticing that 2x and 7, if I move 2x over, that will stay positive. So I'm going to subtract 2x on both sides. While writing this, please write 2 and x, not just minus 2, because those are not the same thing and they are not combinable. 2x minus 2x cancels out. We're going to bring down 5, so we're left with 5 equals 7x minus 2x. So if I have 7 things and I take away 2, I'm left with 5x plus 10. Now, a lot of times I see students be very tempted to move this 5 next. But if I move the 5, I'm left with nothing on this side. So we get 0 equals 5x plus 10. And I'm not anywhere closer to solving for x. Now just everything's on one side of my equation. So instead what I'm going to do is I'm going to move the 10 over. Why am I subtracting 10 here? Well, I'm subtracting 10 because it's the inverse of addition. I'm not going to use the word opposite because that's technically not the right math vocabulary. I want you guys to get used to using the word opposite or inverse. So 10 minus 10 is 0. 5 minus 10, be careful. If you have $5 and take away $10, you are left with $5 short. So it should be negative 5 equals 5x. And then just like as before, first eliminate the constant being added or subtracted. We did that. Now we're going to eliminate the variable being multiply or divide. In this case, we are multiplying 5 times x. So we're going to do the inverse of multiplying, which is division. This will leave us with x equals negative 1. Well, thank you guys. I hope you guys enjoyed this first video. Please make sure you guys do a summary of what you guys are learned from this and what you guys took away as part of your Cornell notes. Thank you.